Welcome back to the Dargslan series. This is part 14, and today we're cracking open how Linux actually stores your stuff. The whole journey comes down to a simple chain. A disk gets carved into partitions. Each partition gets a file system, and that file system has to be mounted before you can actually use it. Keep that four-step picture in mind because everything we do from here, starting with the lsblk command, is just walking through those layers one at a time. Here's the roadmap for the next few minutes. We'll start with that three-layer model: disks, partitions, file systems. Then meet lsblk, the command that shows you the whole storage tree at a glance. From there, we'll practice mounting and unmounting by hand. Make those mounts stick across reboots with X or fstab. Compare the three file systems you'll actually run into: ext4, xfs, and btrfs. And finish with df and du, the two commands that answer every "where did my space go?" question. So let's start with that three-layer model. At the bottom, you've got the disk itself, the physical thing, an SSD or a USB stick, which Linux names something like dev-sda or dev-nvme0n1. You then carve that disk into partitions, slices that act independently, named SDA1, SDA2, and so on. And finally, on each partition, you put a file system, ext4, xfs, or btrfs, which is the actual structure that organizes your files and folders. Disk slice structure. Keep that picture in your head and almost every storage problem becomes easier to debug. And the easiest way to actually see that model on your own machine is lsblk, short for list block devices. It draws you a little tree. Here's SDA, a 500 gig disk, split into three partitions: a small EFI boot partition, the boot partition, and the big root file system mounted at /. Below it, a second disk, SDB, holding a single 1.8 terabyte partition mounted at /mnt data. If a mount point is blank, that partition exists but isn't currently in use. And if you add the F flag, lsblk will also tell you which file system is on each one. And that mount point column is exactly what this slide is about. A file system sitting on a partition is just data in waiting. It only becomes usable once you attach it to a directory in your tree. So the recipe is 3 small steps. Make a folder to serve as the mount point, like mnt data. Run sudo mount with the partition and that folder. And when you're finished, sudo umount to detach it cleanly. That last step really matters for USB drives. Always umount before you pull the cable, or you risk corrupting the file system. But mounting by hand only lasts until you reboot. Then it's gone. To make it permanent, you add a line to sys etc. to fstab, and Linux will mount it automatically on every boot. The line has 6 fields: what to mount, where, the file system type, options, and 2 numbers at the end. Prefer the UUID over dev-sdx, because device names can shift around when you add new disks. The UUID stays the same. For options, defaults is fine most of the time. Dump is almost always 0. And the last field controls fscake order at boot: 1 for root, 2 for everything else, 0 to skip. Now, here's the catch with fstab. A single typo can stop your system from booting, so always test before you reboot. Start by grabbing the UUID with sudo blkid, then open the file with sudo nano and add your line. The magic step is sudo mount, A. It tries to mount everything in fstab right now, and any errors show up in the terminal instead of biting you at the next boot. Finally, run dfh to confirm your new mount point is there, at the right size. Now, when you actually format a partition, you'll need to pick a file system. And on Linux, there are 3 you'll bump into most often. ext4 is the safe, boring default, mature, universal, and what Ubuntu and Debian hand you out of the box. XFS is built for big files and high throughput, which is why Red Hat and CentOS use it for databases and heavy workloads. Just remember it can grow but never shrink. And btrfs brings modern tricks like snapshots and copy on write, and it's the default on Fedora and OpenSUSE. If you're unsure, xt4 is always a safe bet. So let's put it all together. A fresh disk to a working mount in just 3 commands. First, sudo fdisk on the raw device opens an interactive editor. Press N for a new partition, accept the defaults, then W to write it. Next, mkfs.xt4 lays down the file system on that new partition. Note the 1 on the end, since we're targeting the partition, not the whole disk. Finally, mount attaches it to a directory like @mnt-data, and you're in business. One word of caution. mkfs wipes whatever's there, so triple-check that device name. There's no undo button. Now that your file system is mounted, you'll want to keep an eye on it, and that's where df and du come in. They sound similar, but they answer very different questions. dfh is your fuel gauge. It tells you how full each mounted file system is, one tidy line per mount. doh is more like weighing each suitcase. It walks through directories and shows you which folders are actually hogging the space. So when the disk fills up, df tells you that it's full, and do tells you why. So let's put those 2 tools to work in a real emergency. When you hit that dreaded no space left on device message, start with dfh to see which mount is actually full. It might just be var or tmp, not your root file system. Then drill down with du, sorting by size, to find the heaviest folder. Check the usual suspects next. Log files in var, log, old kernels in boot, leftover tarballs in tmp. And if df says you have space but writes still fail, run dfi. You might be out of inodes, which is a whole different beast. Before we wrap up, here are 4 oddballs worth knowing about. Things that show up in the mount world but don't quite fit the simple disk partition file system picture we've been building. Swap is disk space pretending to be RAM, used when memory fills up. Check it with swappin. Show. NFS lets you mount a folder from another machine as if it were local. A bind mount makes one directory appear in 2 places, no copying involved. And tmpfs is the opposite of swap. It's RAM pretending to be a disk, which is why tmp is so fast but empties on reboot. Now, before you go off and start editing fstab yourself, let me save you some pain with 3 classic mistakes. First, never use dev sdx names in fstab. They can shuffle between boots, and suddenly your system won't boot. Use UUIDs instead. They're glued to the partition itself. Second, always run sudo mount after editing fstab. If there's a typo, you'll know immediately, instead of discovering it in emergency mode at 2 a.m. And third, when df says the disk is full but do disagrees, it's usually a deleted file still held open by some process. Run lsa-fas grep deleted to hunt it down, then restart that service. So let's pull all of this together into a small cheat sheet you can keep close. lsblk gives you the whole picture. Disks, partitions, file systems, and where they're mounted, all in one tree. dfah tells you how full each mounted file system is, while do-esh zooms into a single directory. Sudo blkid is your go-to for grabbing UUIDs when editing fstab, sudo mount. Attests that files safely, and mkfs xt4 formats a fresh partition. Just remember, that last one wipes everything, so double-check the device name before you hit enter. And before we close out this part, let's lock in the 5 ideas worth carrying with you. Always remember the 3-layer model. Disk, partition, file system. Because it makes every storage problem easier to reason about. Reach for lsblk first, mount and unmount deliberately. Trust UUIDs over device names in fstab, and lean on df and du together. When they disagree, that gap is usually telling you something interesting. And that brings us to the end of part 14. Next up, we shift from understanding storage to protecting it. Part 15 is all about backup and sync. We'll look at rsync for mirroring directories, tar for packaging archives, snapshots for point-in-time recovery, and the one backup philosophy that genuinely saves you when things go wrong. See you in the next part.